Okay, good afternoon everyone. So I'm going to talk about two things now which don't fit together very well actually. So it's pond aquaculture and seagrasses, but unfortunately those two things are actually forced to stay together in quite a few places. But well, first I want to take you into the subject. So most of you will be familiar with this concept of seagrass responding to increase in nutrient concentrations on the first hand, like with growth. So I really like it in a way. But then after passing a certain threshold, it would just decline. So they show first like physiological changes, like negative response in that. They have morphological changes, and in the end, meadow responses. So we have heard quite a few talks here, and yeah, it's generally known that seagrasses are disappearing. So mainly this is due to like agriculture and urban effluences. And so they're mainly bound to river exports. So there has not been too much information about pond aquaculture effluents, which are not necessarily bound to rivers. There's been an enormous increase in shrimp aquaculture production over the past, let's say, 30 years. And it's mainly bound to China as well as Southeast Asia. And so it's not the odd pond due to this development. So actually, in fact, we find huge clusters of ponds in kind of relatively close areas. And there are effluents drained from them. So it's actually getting a significant cause of anthropogenic eutrophication by now. So the study area is about 2,000 kilometers from here. So it's the island, Chinese island Hainan. And it's situated in the marginal tropics. So here in the 60s, we still found extensive mangrove forests. We have fringing reefs, and within the back-reef areas, there were extensive seagrass meadows. But unfortunately, yeah, by now, most of the mangrove area was actually replaced. And so by now, we have about 40 square kilometers of pond aquaculture, mainly of intensive or semi-intensive production. So there's no standardized procedure, and the effluents drained into the natural waterways without prior treatment. What we know of these effluents is that they are really high in dissolved inorganic nitrogen, mainly ammonium, but also in dissolved organic nitrogen. There's also a lot of total suspended matter released from them, mainly in form of phytoplankton, and the variability is really high, so there's quite high variability in the concentrations, as you can see. We also know that the effluents are characterized by high stable nitrogen isotope values, and by doing this we could actually prove that the nutrients available within the back-reef areas are actually really coming from the aquaculture and not from any other sources. But the question, or like the objective of the study we did here, was to evaluate the impact of pond aquaculture effluents on the adjacent seagrass meadows over spatial and temporal scales. So the questions were, does seagrass species distribution correspond to the magnitude of pond effluent disposal? Are there differences in seagrass distribution between dry and rainy season? What is the long-term impact of pond effluents on the seagrass distribution? And what are the main drivers related to aquaculture effluents determining seagrass distribution? So within our study area, we selected 3 study sites so that were varying in pond aquaculture pressure, let's put it. So Nayeli has had a low pond exposure, so there were only 4 hectares of ponds in the backland. There was a site Shangqi with really heavy aquaculture exposure, so there were about 870 hectares right away in front of them. And Qingge was kind of intermediate in pressure. So within those sites, we selected 5 stations along a 1,000-meter distance gradient from shore. So I have to say the seagrasses are intertidal, so they're basically at all stations have the same depth, more or less. So we sampled during the rainy season 2008 and the dry season in 2009, and then again 9 years later during the rainy and dry season 2017. So I've got to say right away that actually during the times when we sampled, we actually found all sorts of weather conditions, so actually this concept didn't really add up. What we sampled for were, on the one hand, environmental parameters, meaning dissolved nutrients, photosynthetic active radiation, chlorophyll A, total suspended matter, and quite a few more. And in terms of seagrasses, I'm now only showing like seagrass species abundance and shoot density, which we did shoot counts. So here is the data basically. It's from the 3 stations, and like in the rainy and in the dry season. So what becomes obvious right away is in the 2 aquaculture impacted sites, we have a significantly lower species density, and also we find much less species. So actually in the Yelin, which was hardly influenced by aquaculture, we have 6 species occurring, while in the others we have only 2 or 4 species. Thalassia hemprichi was actually the dominant species, so which we was finding, and we found at all sites. And at the aquaculture impacted sites, there were actually more density found further offshore, while there was hardly anything like close to the shore, while it was the opposite in Yelin. There was also a seasonal trend, which was most obvious in Yelin, so much less density during the dry season. But this was probably because actually water temperatures dropped quite a bit during the winter months, and we just sampled in March. So probably it was kind of, they just kind of were waking up, so they passed their dormancy stage and were coming up again. So if we now look at the data from 2017 in comparison to that, you can see actually that we cannot see much. So it was actually almost everything had gone. So the 2 impacted sites by aquaculture effluents, the seagrasses, had gone completely. And also at the site Yelin, so there was a drop, but still quite considerable biomass. So this was in both seasons, so it wasn't just like an event, so they didn't come back, so it was really during the whole year they had just been gone. So what was the reason for it? Actually, so the seagrasses have been standing the conditions there next to the aqua ponds for more than 30 years. So the ponds were actually created in the 80s or 90s. And so what happened? Well, so this is nutrient data. So we have dissolved inorganic nitrogen versus total seagrass shoot density at the 3 sites. And in fact, we see that the nutrients concentrations were highest in Changchi. And also in Chinga. I'm not going to talk too much about this data, so this is actually part of the weird seasonal pattern we found. We had a lot of rain there, so this was kind of bound to river input there. So now adding the data from 2017, we see that it was the same. We also had higher DIN concentrations in Changchi and Chinga, and also in biomass, or in seagrass density, as I was saying before. But most important is actually that the dissolved inorganic nitrogen concentration actually were quite a bit higher in 2017 than before. So the question was, really, wasn't there a change in pond management over the 9 years, maybe? And in fact, the dissolved inorganic nitrogen concentrations from the pond effluents, they confirmed that we had almost more than twice as high DIN concentrations in 2017 compared to before. So we're not quite sure actually what they were doing, so what happened in terms of management to the ponds, but most likely, so there were some other, there were like higher density, stocking densities applied, and also the water, the way they released the effluents had changed, so we're still going to look into that closer. So when we put all data together into one graph, we see that there is actually a correlation between the shoot density and the DIN, but it's actually not really good. So, well, actually all we can conclude from is that like from higher than 8 micromole dissolved organic nitrogen, we hardly find any seagrass. And actually the same is when we look at total suspended matter as an indicator for light. So we also find a correlation, but it's actually not great. So, well, we can say that from higher than 14 milligram per liter total suspended matter, seems like there's hardly any seagrass still there. So, but what also probably it has an effect. There seems to be a relation. So, compared to like this former situations where we still had mangroves retaining nutrients, If you compare that, actually the impact of nutrient increase actually caused a situation like that, where we had a lot of phytoplankton and there was lots of shading on the seagrasses. But there's also quite a bit of data which isn't explained by this trend alone. So actually there are also other environmental drivers involved, which on the other hand are also related to dissolved inorganic nitrogen concentrations. So this is on the one hand shading by epiphytes. There we have some evidence from the site Chinga that there we had significantly more epiphytes being standing on the seagrass blades. And by the epiphytes again, they have different control mechanisms. So they could have been changing like this pattern before and explaining some kind of loss also at lower concentrations. On the other hand, sulfide invasion may cause like really spontaneous seagrass die-off, and we have some evidence that at the most affected site, or most exposed site, Changchi to effluents, actually here also had the lowest stable sulfur isotope values, which is actually showing that we have some types of sulfide intrusion into the leaves here, so would have also could have caused the die-off. So all in all, it's actually tricky. So there are, as you all know, many drivers involved. What we can conclude that it really seems that long-term exposure to aquaculture effluents causes seagrass loss and degradation, and that there also is a relation of seagrass distribution and the magnitude of effluent exposure. However, the role of the aquaculture-related environmental drivers on the seagrass loss is really difficult to disentangle. However, as there is actually always a correlation of all different drivers with dissolved inorganic nitrogen, we really think that this is dissolved inorganic nitrogen in aquaculture effluents really has a key role, which should be managed. And in general, better pond management and especially the effluent management is really needed in areas where there are seagrasses existing so close to the ponds, which is actually happening in quite a few places, as we think, as you know, like how big this actually increase in aquaculture has been. And as actually we know that there are some restoration projects planned for some sites, for example in Changchi with the most effluents. So we really want to stress here that we think that managing the water quality would be a big thing to do first to actually make the restoration successful. So I'm about to end. I just want to make some advertisement to my colleague's talk, because I only talked on like the meta responses, but my colleague Esther is going to talk about physiological and morphological responses in this context at 7:30 actually here. So thank you very much for your attention.
Yep. Any questions?
Nice talk. Results are pretty compelling. Is there any appetite by the aquaculturists to actually reduce the amount of effluent coming out or reduce the nutrients coming out, or they're just not worried about that?
Well, I think they are worried too, because they actually need the water. So that's actually part of the water they take up to fill the ponds where they're actually doing then the shrimp farming or fish farming in. So they're also worried in a way, but most of them are actually not aware that there is seagrass. So they're not really worried about like the surrounding the reefs and the seagrass, but just, for the water quality they maintain in their ponds themselves and to have actually good crops coming from it.
Depressing.
It really is.
Sorry, I got in a little bit late, but I might have, so excuse me if it's a trivial question. I would consider, all this is based on a classic bottom-up control of seagrass control. If it could consider, or any evidence, just even anecdotal, that it might have changed possibly the top-down control component, which would allow the epiphytes to actually dominate. So there's a switch in the system where seagrass might have actually stimulated to seagrass stimulating microalgae through epiphytes, through a top-down control change, overfishing and so forth, and even configuration of the grass at the edge itself.
Well, yeah, we have, but the thing is, there we hardly find any top-down control at all. So actually, there's been a lot of fishing pressure there. So when we actually go to there, there's hardly any fish. There's also no urchins. There's nothing really which seems to control, because it's just collected right away, it seems. Well, over the last 10 years, it has been the case, yes. We're not sure of what happened before. Yeah, well.
Well, thank you very much, Lucia. So our next speaker